Alright, Algebra, Chapter 1, Section 5 about equations. Before we can talk about equations, first let's talk about an open sentence. A mathematical statement with one or more expressions is called an open sentence. It is neither true nor false until the variable has been replaced by specific terms or values. The process of finding the values that make the statement true is called solving the open sentence. The true replacement value is called the solution of the open sentence. So an equation is an open sentence. A set is a collection of objects or numbers. The set of numbers from which we choose replacements for the open sentence is called the replacement set. Each number in the set is called an element. The set of elements that make the open sentence true is called the solution set. Okay, so you may want to stop and read those two paragraphs again and make sure that you understand the different terms that we're going to be using. Alright, let's look at the mathematics of it all. Find the solution set for each equation if the replacement set is 3, 4, 5, and 6. So we're going to make a table. And if this was your paper without a table provided, I would want you to make a table here like I have. A is what we're going to be plugging in, and it looks like we're going to be plugging in 3, 4, 5, and 6. The open sentence is 4a plus 7 equals 23. This is also known as an equation. Alright, and we're going to be checking to see if it's true or false. In other words, when I replace a with 3, do I get 23? 4 times 3 is 16, or not 16, is 12, and 12 plus 7 is not 23, so that would be false. 4 times 4, now that is 16, plus 7, and that is 23, so that is true. And 4 times 5 is 20, plus 7, oops, I didn't change colors, oh well, 27, that does not equal 23, so that is false. And then 4 times 6 plus 7, of course, doesn't equal 23, so that is also false. So the only solution, the only number in our solution set is 4. It was the only one. So it's a set of one number. Our solution set A is only 4. So that's possible to have a set with only one number in it. Sometimes an equation or open sentence can be solved by only simplifying one side. So here B is already isolated, so if I just solve using my order of operations, in the end I'll be finished. I will have solved for B. So let's see. Please excuse my dear Aunt Sally. I start with my exponents, so 2 to the third power makes 8. Then I need to take care of my parentheses, so 8 minus 2 is 6. Then I need to multiply before I add, and 4 times 6 is 24, plus 3 is 27. So I've solved for B, and I didn't have to worry about the fact that B was already isolated here. Alright, some equations have a unique solution, like the one we did earlier where we found one solution. Others do not. Let's talk about the difference. Why would some have a unique solution and why would they not? So if you can squeeze in the space provided here, we're going to go ahead and say 3 squared is 9. I'm going to see how n is not isolated, so I need to go ahead and simplify as much as I can. And 9 plus 7 is 16 divided by n. Alright, so the question we need to ask ourselves, 16 divided by what number plus 4 will equal 8? Again, like our first example, the only number that's going to work is 4. N here needs to be 4. Or our solution set for n would be 4. Because 16 divided by 4 is 4, plus 4 is 8. Now, in contrast, let's look at example B. I'm going to simplify both sides as far down as I can. So I have a negative, and 12 plus 2 is 14, equals n, and 6 minus 2 is 4, minus 9. So here I have 4n minus 14, and here I'll have 4n minus 9. Now, no matter what value I substitute in for n, in other words, I replace n with whatever value, the problem I have here is negative 14 or 4n minus 14. It's always going to be 5 less than minus 9. If we were talking about money, I have 4n dollars, take away $14. Here I have 4n dollars, take away $9. Here I am more in debt than I would be if it was just negative 9. So this side is always going to be 5 less. So the problem is this is not a true statement. These are not equal. Therefore, there is no solution. So it would be a null set. Our answer here would be null set or no solution. You can do that either way. There's not a solution to that, and I have to work on my squiggly brackets. Okay, now flip your paper over. An equation that is always true is called an identity. Highlight that. We talked about identity earlier. If it's always true, then it's an identity. So let's see if example 4 turns out to be an identity. 5 plus 8 divided by 4, so I take care of division first, and 8 divided by 4 is 2, plus 3k equals, and I can't add k plus 32, so let's distribute our 3. That'll give us 3k plus 96 minus 89. I dropped my parentheses because I took care of distributing my 3. There's nothing to distribute here, but they are like terms, so I can add 5 plus 2 is 7 plus 3k. And here I have 3k, and 96 minus 89 leaves me with a positive 7. So here we have 3k plus 7 and 3k plus 7. The commutative property is happening here. They are equal. They will always be equal no matter what value I substitute in for k. So this is all real numbers, and we do all real numbers with a capital R. That would be our solution set. This stands for all real numbers. All right, so that's one of each kind. Some equations have 2 variables. Okay, that means maybe an x and a y, or an m and an n, 2 different unknown values. It is useful when there's 2 to make a table of values and to use substitution to find the corresponding value of the second variable. So let's look at what they're talking about here. In example 5, Dalia pays $16 per month for a gym membership. Okay, so every month she's going to be paying $16. In addition to her $16, she pays $2 per Pilates class. So $2 per class. Write and solve an equation to find the total amount Dalia spends in 1 month. Okay, so we're only going to look at 1 month, not a year. So in 1 month, I know she's going to be spending $16. And the only way that that amount is going to increase is if she takes Pilates classes. So I'm going to let C stand for number of Pilates classes, or you could have just said number of classes. All right, and I'm going to say T stands for total cost per month, because that's what they're asking us. How much does she spend per month? So T, her total cost, equals the $16 that she has to pay no matter what, plus $2 for every class that she takes. So this would be my equation. I have two variables. So it's suggested in italics that we make a table. And a table would look something like this, where C stands for the number of classes she takes. Our process is going to be $16 plus 2 times C, that's dollars also, and that's going to give us our total per month. So I've made a table, and it says solve the equation and find out how much she spends if she takes, whoops, not tool, I think that's supposed to be if she took 12 classes. So if she takes 12 classes, it's going to be 16 plus 2 times 12. 2 times 12 is 24. 24 plus 16, that'll be a total cost of $40. So I didn't really need a table because they didn't give me a lot of options here, but if they'd said 12 classes, or let's just say, let's check it just on our own, let's say what if she took 3 classes, then it's going to be 16 plus 2 times 3, and 16 plus 6 would give us $22. So that's how you would use a table to show our different total costs depending on the number of classes that she takes. Okay, if you flip on over to the next page, we're going to compare expressions with equations. An expression, here's an example of an expression, 3x plus 5. Now, to have an equation, it needs to have an equal sign. So 3x plus 5 equals 2 makes it an equation. So equations, the root word in equation is equal. It must have an equal sign. All right, finding the value for a variable in an equation that makes the equation true, it's got to make it true, that is called solving the equation. Okay, the value is the solution. Now I'm going to work one more word problem with you, and I want you to do the last 2 word problems on your own. Mr. Pickens pays $10 per month for Netflix. He can also rent movies individually for $1.50. Now notice I'm going to define my variables before I start solving the equation. Write an equation that represents the total amount he spends in a month. So there I go. I'm going to make T total cost per month. Okay. Now what's my other variable? He can also rent movies for $1.50. I'm going to make M stand for number of movies that Mr. Pickens rents. So my total cost is $10 no matter what, plus $1.50 per movie. That's my equation to solve this problem. Okay? Then find out the total amount he spent if he rented 3 movies. So now I'm going to change my color, and I'm going to say 10 plus $1.50, and in place of $1.50 I'm going to plug in, or excuse me, in place of M I'm going to plug in 3 because that's how many movies he rented, and that's going to give me 10 plus $4.50, and so $14.50 is his total cost. And notice I went horizontally instead of vertically, and that was just because of space. So as you work yours, you may want to start your equation over to the right and be able to work neatly. I always like to show my students how it's like a pyramid, an inverted pyramid, where you start out with 10 plus 1.50 m, and then as you work and simplify, you keep getting smaller and smaller until you get to the bottom. All right, let me see your inverted pyramids for the next 2 problems. Thank you and have a great day.